Hello dear students, welcome to ECE Academy Benefactor. In this class we will be seeing the multiplexer implementation using 8:1 mux. The topic is from combinational circuits. The subject name is digital electronics. Let us solve a problem for the design of multiplexer, implementation of multiplexer. The given problem is implement the following Boolean function using 8:1 mux. The function is f having 4 variables a, b, c, d, having this terms. Okay. Now let us see the solution of it. I have written the Boolean function as it is. If you look at it, it is not in the standard SOP form. SOP stands for sum of product form. It is not in the standard SOP form because each term is having one missing literal. In the first term C is missing, in the second B is missing, in the third A, and in this one B is missing. So, we have to first change the given Boolean function into standard SOP form. We can convert this one into standard SOP form by having this equation. We know A plus A bar is 1 or C plus C bar is 1, B plus B bar is 1. So, what will be D plus D bar? It will also be 1. So, the same expression is used here. In each term is multiplied with 1. This term is multiplied by 1. What is 1 here? Here the missing literal is C. So, I have written C plus C bar. Here the missing literal is B. So, I have written B plus B bar. Here A plus A bar. And in this last term B is missing. So, it is written as B plus B bar. Okay. Now, after this open the brackets, you will be getting it as A bar B C D bar plus A bar B C bar D bar plus A B C D and so on. Okay, after opening the brackets and writing, you are getting this expression. Now, you also know that A plus A is A. So, if you look at these two terms A B bar C D and A B bar C D, these two are same, that is A plus A. So, we can write 1A. A plus A is A. So, for these two terms we can write only single term. So, it is written A bar B C D bar plus A bar B C bar D bar plus A B C D plus A B bar C D plus A bar B bar C D plus A B C bar D plus this last term A bar B bar C bar D. Okay, now we got this Boolean function in standard SOP form because now each term is having every literal A, B, C, D. Now, you have to convert it into their binary numbers to find the list of minterms. Okay. So, you know bar is A bar is 0 and B is 1, C is 1 and D bar is 0. So, you are getting here for this term 0, 110 and so on. We have written the binary number for our convenience to write the list of minterms. So, here this is 6, 4, 15, 11, 3, 1 and 5. Those list of minterms are listed here 1, 3, 4, 5, 6, 11 and 15. Now, we have these are 4 variable function, but we need to implement using 8:1 mux. So, definitely we have to go for an implementation table. So, it is 8:1 mux means it will have 8 inputs. 8:1 mux will have 8 inputs from D0 to D7. So, let us first complete the implementation table. Inputs are D0, D1, D2, D3, D4, D5, D6, D7. And the Boolean function is having 4 variables A, B, C, D. The first variable is written here A bar and A. So, this is the outer structure of the implementation table D0 to D7 A bar A. Inside this implementation table we have written numbers from 0 to 15. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Now we have to circle the numbers which are there in this list of minterms. So what is there? 1, 3, 4, 5, 6, 11 and 15. We have circled the numbers which are in the list of minterms. Now let us write the output of this one. Looking at this column, D0 column, none are circled, so we write it as 0. Here in D1 column, above one is circled, so it is representing A bar. Here none are circled, so 0. Both are circled, 1. Here above one is circled, so A bar. Above one is circled, A bar. Above one is circled, A bar. In this D7 column, the bottom one is circled, so it is A. So now what we understand from this implementation table, the input D0 is to be connected to 0, D1 is to be connected to A bar and so on, D7 is to be connected to A, which is shown here. 8:1 mux will have 8 inputs starting from D0 to D7, and it will have 3 select lines S0, S1 and S2. And these 3 select lines are connected to the variables B, C, D. The function is having 4 variables A, B, C, D. The first variable is used in the implementation table and the other 3 variables are used for the as selection lines. 8:1, 8 inputs, 3 select lines and 1 output. The output is function f. Now where is D0 connected? D0 is connected to 0 and D2 is connected to 0. So here D0 and D2 are connected to 0 input. Now D1, D4, D5, D6, that means D1, D4, D5 and D6 are connected to A bar. So here is input line A and we have taken another line connected to NOT gate. So the output of this NOT gate will be A bar. So this line is carrying A and the other line is carrying the A bar. So D1, D4, D5, D6 are connected to A bar. D3 is connected to 1. Here D3 is connected to 1 and D7 is connected to A. It's connected to A. So in this way we are able to implement the 8:1 mux for the given Boolean function. I hope the class is clear. So what is the first task if it is not given in the standard SOP form? First we have to convert the given Boolean function into standard SOP form by using the formula C plus C bar is equal to 1 or A plus A bar is equal to 1. After converting into standard SOP form, write the list of minterms, write the implementation table, circle them and find each input is to be connected to what value and then draw the implementation table. I hope the class is clear. If you have any queries, you can post in the comment section. Thank you. Good luck, students.